So how do we draw loci for complex numbers? That's what we're going to look at in today's video. The first thing is, what do we mean by that? And the best way to do that is just to get into the first case. So if we're given a specific complex number, z1, and as I said, this is a complex number, and we want to draw the loci of z, complex number z, that satisfy z minus z1, the modulus of z minus z1 is equal to some r, and r is going to be some real number. Okay, so what do we want our loci to look like? Well, we're trying to draw something that represents, on the Argand diagram, the point z which satisfy this equation. And for this sort of setup, what we draw is on a terribly drawn Argand diagram. You got to make sure you do yours neater than this. But we find our point z1. So that there is z1, okay. And then we draw some circle of radius r, okay. And the points on this circle are all values of z that will satisfy this equation, okay. So that's the first setup. One thing to note is, on the specification, you're told to know how to solve these for inequalities as well. So, well, if this is less than r, all you do is you draw the same circle, but now it's all the points inside the circle where it's less than r, and greater than, you just draw all the points outside, okay, you just shade that on. So that's our first case. Our second case is if we've got z1 and z2 are both complex numbers, specific complex numbers given to us, and we want to find values of z that satisfy z minus z1. The modulus of that is equal to the modulus of z minus z2. Okay, so what do we do here? Well, we take our points, z1 and z2, and we draw a straight line between them. Straighter than that probably, but I'll do just for demonstrating. And then we find the midpoint of this line, so this point here we're going to say is the midpoint, and then we draw a line straight through the midpoint, and this line will continue on and on. And this line's perpendicular to our line between z1 and z2. So the points z that satisfy this equation are the points on the perpendicular bisector between, the perpendicular bisector to the line, the straight line between z1 and z2. Okay, so that's how you solve these setups. And again, if we think about the greater than, right, and again we want to look at the less than or equal to case, the inequalities, right? And to consider that, well, we've got to think, what's this equation telling us? The reason it's ended up being the perpendicular bisector of the line between z1 and z2 is the modulus of z minus z1 means the distance between z and z1, okay? And the same for z1 and z2. So we're saying, when is the distance between z and these two complex numbers the same? Well, it's when it's on this bisector of this perpendicular line at the midpoint between z1 and z2. I mean, that makes sense. So we want z minus z1 to be greater than z minus z2? Well, that just means z has to be further away from z1 than it is from z2. And when is z further away from z1 than it is z2? Well, that's in this red segment beyond this line, okay? Coming all the way out over here. Alright? Any points over there, z1 is further away from z than z2 is, so this left hand side will be bigger. Say we want the right hand side to be greater than, well, we want z being further away from z2, so that's just this side of the line. Okay, so hopefully this all makes sense. If you do have any questions about complex numbers or any other further maths related queries, please be sure to let me know in the comments, or you can email me if you want as well. If you did enjoy this video, please support me by liking and subscribing, and I hope to see you in the next one.